Okay, a velocity selector is a specific device that uses a magnetic field and an electric field to allow a charged particle to move through undeflected. So that means it moves through in a straight path, not deflected. It doesn't curve, it doesn't fall. So let's look at maybe a plate here, and we'll have an oppositely charged plate there. What would that be? If you had a plate with some charge on it here and a plate with some charge down here, it looks like a capacitor. Okay, so it could be two parallel plates. What exists between these two parallel plates? A uniform electric field. That's right. So we've got this uniform electric field like that. If I put a positive charge in that field like that, what's going to happen to that positive charge in that electric field? It's going to move straight down. It would be forced straight down. So it would just go straight down. Okay? What if I gave that positive charge a velocity to the right? What would it do? Oh, kind of curve down, kind of like what? Yeah, because isn't the electric field to the gravitational field as the charge is to a mass? If the gravitational field is down and you throw... So a free body diagram of the forces acting on this charged particle as is would just have an electric force directed straight down. If I wanted it to move through undeflected, what do I need on that free body diagram? We'll need a force that's directed up. Now, I've already used an electric field, so I'm not going to use another electric field, but what's another alternative I could use? A magnetic field. So I could have a magnetic force that's up. So an F sub B there. All right, so let's do the let's do. So if I have a positive charge and it is moving to the right, and I want the force to be which way? Put your left hand away. We're going to use a right hand. Okay. So which way is our positive charge moving? All right, so first of all, if you're looking for force or something with the force in it, you're going to use the right hand rule for the force on a moving charge. Okay, so you can go ahead and assume the right hand rule position with your right hand. Okay, your index finger is the velocity, your middle finger is the magnetic field, and your thumb is the force. So in my picture, my velocity is to the right, so I'm going to stick my index finger to the right. And which way do we want the force to be? Look at the free body diagram. We want the force to be up, so that puts your middle finger directed into the page or into the screen. So how would I draw into the page for my magnetic field? With a bunch of X's, that's right. So I'm going to draw some X's. So those would be the magnetic field lines needed to balance the electric force. So now that we have that free body diagram, we're going to sum our forces. And so when I sum the forces, we'll have the magnetic force is up, the electric force is down, and if I want it to move undeflected, I set it equal to 0. So the big idea is that the magnetic force has to balance an electric force in a velocity selector. That is the big idea. I love a big idea. Now, substitute into those two values. And in most cases, this sine theta is going to be 1 because we'll have a 90-degree angle because that's what we do in this course. We're not going to have anything crazy, so I'll have a 90-degree angle, which will give us 1 there. So they cancel out your Q's. And if you may want to remember this as the velocity selector equation.